So, Gorka, were we able to discuss the topic, like complete the
Yep.
topic?
Yep. Mostly everything except three sections have an assignee, and you were assigned an easy one, the image one. So if you want to take another one, feel free.
No, I think I'm good. Who did go? Who was assigned the attachment one?
Yes, who?
You.
Yep,
Okay.
that's me.
Yeah, that was. So if everyone is around, I'm not sure. I can start with the topic. I'll just copy paste all the content from Glance. I have mentioned the whole topic in the Glance side.
Oh, are we recording this session? I think,
Yes, recording is enabled.
yeah, thank you.
So yeah, should I start, John?
I think so. Yeah, we're 4 minutes. We're 4 minutes past, and it looks like we've got a sufficient number.
Okay. So basically, this topic is more of a glance one, but since I'm touching the Cinder store, I would be great. It would be great to receive some feedback from the Cinder side as well, like how feasible this could be. So basically, the use cases, like I have seen, like when people want to. So the most common use case is when people want to decommission a particular glance store and want to move all their images into the new store that they want to use. Let's suppose they are using Swift currently and they want to migrate all their images to the Cinder store, and their images are like very, I mean, in terabytes, like they have huge file sizes. Glance does provide a mechanism to do it with the copy image import plugin, which uh, I mean, downloads the image into a staging directory, and then it puts it in the destination store, and then we manually delete it from the source store. So this is kind of a two-step migration process: copy plus delete. Uh, right now, we don't provide any interface for the specific stores. So this is the generic mechanism that happens. So we cannot leverage the features provided by specific stores to optimize this whole thing. So like in case of Cinder, we can easily, like from migrating from one Cinder store to another, like we can easily perform the retype operation. Uh, like if I have a Cinder store configured with Dell backend, and suddenly the consumer, like the customer thinks of using, instead of Dell they want to use a NetApp. Sorry, it won't work in that way. In Cinder, we'll use the generic migration. Okay, yeah, I will take another example. Like in case of two NetApp backends that they have configured, they want to decommission one of them and want to migrate all the images to the other one. Then they can use the optimize retype operation on the Cinder side to perform that, and it will migrate all the volumes, and then they just need to register the new location of the new destination of the volume that is stored. So basically, this operation could be performed in a much faster way, and same case could be applied for even the RBD store as well. Like when we are using RBD and they want to migrate from one pool to another, like they have multiple stores with different pools configured and want to migrate all their images, this could be useful. So I understand that this is not a very common use case, like it happens once in a while. And yeah, but I have seen people like it takes time. So yeah, I was thinking if this could be an implementation, and this is the motivation from the Cinder store perspective. And at the same time, I was thinking if we could implement something generic on the Glance side as well, like a generic migration path, like the previously mentioned operation, copy image plus delete into one single API. So that
Basically, I have one question here. You have mentioned the use case like if someone wants to decommission the store and introduce new store. So in that case, there will be multiple images in that store. So anyway, as earlier, you have to copy each image one by one, right, with your new API as well.
yeah.
So doesn't it better that we should have a utility which will copy all the images in one command to the destination store?
Yeah, that
Because I think if you want to introduce optimization, you can introduce it in the store at the store level, which can be used with existing API as well.
you mean the copy image import plugin?
Right.
So
So copy image gives call to with copy image, you copy the image to the staging store, right? Here you are going to introduce whole new mechanism. You are not going to introduce copy image at all.
no, this will be a direct call to the Cinder store, and then that will retype the operation, and then later Glance. So it will return the new location, and then Glance will register that. So it
Okay.
does that.
Okay. In that case, it will make sense. But I still think if there are hundreds of images, then you need to issue hundreds of API calls to copy images and delete it from that store.
Yeah, as you mentioned, the utility will be very useful, but my proposal is some like quite different from that. Like my idea is to provide that optimization on the store level, and as you said, like the utility for migrating 100 images would be useful as well. So, but that could be a different effort.
Yeah, because a few minutes back, I have that discussion in the Glance room that I'm planning to add a utility similar to something like Glance Manage DB Sync. I will introduce new operation in Glance Manage command, and I can pass hyphen hyphen source store hyphen hyphen destination store and the new flag like hyphen hyphen delete from source. So if that flag is present, it will delete the image from the source store after the copying. So
Okay.
I am thinking on that line.
The problem I see with doing it as a whole is that if the service goes down or something like that, the figuring out where things were left off, I think it may be a little bit more complicated, right? Because you're moving in also the operation, you would have to add some way of getting progress, because if we are, the main problem is we are moving terabytes and terabytes, and you do it everything in a single method, then it will take days and days and days. So I'm not saying it's not good, but that probably it makes sense to do it. It just needs also to take into account failure and reporting to to a admin of how the process is going, right?
Right, right. That makes sense. We are planning to implement the progress in that tool as well. But as you said, it will be long operation.
Yeah, and it could even leverage the functionality that Rajat is mentioning, right? It is if the
Yes,
drivers support the optimize for each of the individual steps, do it that way. If it
right,
doesn't, well, you have the normal mechanism.
right. That is why I'm saying, like, in instead of introducing new API, can we find a way to do it in existing API, which we already have image import, which uses copy image plugin?
But as I understand, like the copy image calls the add method of the glance store, which is
Ri-
like creating the image.
Right, right. So
So
what I say is there is a way you can do it in the copy image. Like you have existing locations with you, and you have also a destination store with you. So you can easily check if the source image uh, is same, source destination is same as destination we are providing. Then you can initiate a method, new call itself from that, right? Because in existing image, you already have the source locations with you. You just need to parse through the locations and check your backend type is same as the destination type, and you can initiate the optimized flow.
yeah, so you're proposing it to do it in the copy image plugin.
Yeah, something like that. I simply don't see the use of new API call here.
Okay. The problem I see here is like, so copy image is plugin is basically like, I mean, it doesn't move, it copies. So it exists in two locations. And the optimization that I provide for sender for the retype, it moves the volume from one back into another. Like, so it doesn't exist in the first one. So that both the operations are like in conflict in that case. And so my idea of this implementation, so I proposed a spec, like high level spec for it. Basically, the idea is to just implement the interface methods on the store side. Like for all the stores, we can have this method, new method to optimize this migration, and then provide a new API on the glance side to leverage that. And yeah, I understand your concern, like if we want to propose a new API, but yeah, I failing to understand any other way.
Rajat, one thing, is the use case you're trying to solve the migrate everything, or are there potentially other cases where you would like to cover? The move only some to free space, or because if
Yeah,
it's all or nothing, then Abhishek suggestion of integrating the functionality you want with the other feature that they are looking into, maybe the solution. But if you want other cases, then no.
yeah. So the initial use case was like migrating all because we want to decommission, but at the same time, as you mentioned, like in Cinder, it happens like moving from one tool to another or like to free up space. That could be a case as well. And yeah, with this topic, I also wanted to, so I don't have much of deployment knowledge, so I wanted to know from any operator as well, like how often does this case appear on the glance side for their cluster, for their deployment, and how painful it is for this migration. And if the development efforts justify the whole, pain of the operators.
See, recently I have seen some requests from the customers where they want to migrate from one kind of backend to different kind of backend. For example, they want to migrate from Safe to NFS, or from NFS to Cinder, something like that. Those kind of requests I see, and as there is no way, we just give them solution that you just copy the image from one store to another store and delete it manually from the existing store.
Okay. Yeah, this API I was proposing, it's like the generic workflow would be using both these features, like first copy image, then delete it internally. So it will use both the methods.
Mhm.
And yeah, it could be a two-step process or a one-step process, like, yeah, that way. But yeah, my main focus was on optimization. But as you mentioned, the case mostly is for like RBD to NFS. It would be difficult. Like this one will be helpful when from one sender to another. Either it's the same type of backend, like Ceph and RBD and RBD. If
Mhm.
it's even different, then also sender has a generic way of retyping, like with migration. So that can also be done on the sender side, but it won't be optimized. But yeah, still, I think it would be faster than how Glance does it, because we leverage the DD operation. Like we do the DD copy with the volumes by attaching them. And Glance, in case I think downloads the
Yes,
image, then copies it to the volume. I need to
right.
check the performance numbers for it, but I feel like the Cinder DD would be faster because it is just dealing with the volumes and no interaction with Glance, like back and forth between the APIs, different components.
Okay, I just have
Yeah.
objection with the new API. That's it. I'm pro for this feature. I just don't understand the benefit of having it in the new API itself. That's it.
I think Rajat reason to have it in the new API instead of the copy is because it's out of Glance's control. The steps of copy and
Uh-huh.
deletion. It happens at once in Cinder. You make the call in Cinder itself, that's everything.
But you
Copy
need,
the data, delete.
yeah, but you need to delete that location from the glance as well, and for that you need a glance API call.
Yep.
Even retype deletes the volume from the source. You need to explicitly delete that record from the glance as well. So for that purpose, you need to give a call to glance API call anyway.
That is true.
Yeah, in the generic way, it will be done automatically because copy image does copy and like copy the like add the location as well of the destination, and then delete will remove it.
Yeah. So in short, you are going to provide a new glance command which will internally call two different APIs. One is copy and one is delete, right?
Not exactly API, but yeah, internally it will use that whole code to perform those operations. Yeah.
Okay. I think I will give more comments about it once I see the spec.
Okay. But yeah, as you mentioned, in the optimized path, we do need to like have a separate call to register that location.
Right.
After the retype, the volume returns, then we need to register that.
Correct.
I'm thinking, okay, yeah, the volume type will be changed. So yeah, we need a new location. Else I was thinking the volume ID remains the same. So previously, like Lance did sender :/ volume ID, but now it's sender, then the volume type, and then the volume ID. So it needs to change.
Yes. Basically, you need to add a new location rather than changing. You need to add a new location and delete the existing one from
Yeah.
the glance.
Yeah, okay.
I see the value of it from Cinder perspective. I'm doubtful about other stores. I'm not sure because I never seen we have configured multiple Swifts or anyone has configured multiple Swifts or
Maybe Pete.
even if you have RBD, if you decommission RBD, you don't introduce new pool, you introduce new cluster, right? So that should be optimized. This has optimized value only for Cinder case, as far as I know.
Yeah, if the clusters are different in case of RBD, it won't be useful. Pools, it will be. I think RBD does provide some mechanism to optimally move from one pool to another. Swift, I don't know. Maybe Pete can provide some insight. I don't know if he has ever encountered, like, used the Glance Swift store.
No, I'm not sure why me. I don't think I did.
Okay.
Okay, I think you can do your research for Cinder optimization thing. You can find out the difference, how much performance we can gain with this one. And we can discuss more on the spec about this one.
Okay, I can try to put up a POC to test just the performance numbers, not implement like a whole lot, but just compare copy image plus delete to the optimized retype.
Yep, sounds good.
Okay. Not even just optimized, but like optimized versus generic retype versus the Glance one. Yeah, all three.
Yeah, sounds good.
Okay. Yeah, if anyone has more concerns, they can add it to the spec. Like, it's just a high level overview. I can update with details, but yeah, just wanted to know if it makes sense and good to pursue.
Yeah, as I said, from Cinder perspective, it makes sense. We need to find out more about other stores from Glance perspective.
Okay.
Yep.
Yeah, I can see if someone uses like Swift or NFS or RBD heavily on the Glance side, and
Right. Thank you.
yeah, thanks Abhishek, and thanks everyone. That was all for my topic.
So, Brian, for next topic, are we continuing in Cinder room itself?
I think so. Dan's here. Is
Okay.
Melanie going to be joining us? Okay.
Yeah, I just told her.
Okay. So we can, is she free now? Do you know? Or?
I assume she's, well,
we'll see. Okay. Because it's not scheduled for like.
well, let me see if, yeah, I told her, but she probably thought, you know, that she would wait and join, but let me just see if she can just join. I'd rather get it out of the way.
Right.
I was sitting over on the Glance Jitsi, which a lot of these other people are in, but aren't listening because they're listening to this, I guess. So I was very confused. Like Abby and Pranali and Alan even are there, but also here. So
Sorry, I heard your voice, but I thought you are talking in this channel.
Yeah. It's kind of
Sorry
like,
for that.
yeah, like, hey, yeah, we'll meet you all at the ice cream parlor after school. Honest.
So I wouldn't even try to run both on my system. Wow. Okay.
Yeah, I wouldn't do it either
Mm.
because it confuses other people. But
Right.
I hope I'm no longer there.
well, I'm only in one place, so I can't tell. But
I remember when we used to do it in Blue Jeans, like we couldn't open 2 Blue Jeans at the same time and it would crash the system. But good to know these two works.
I'm not sure that it is good to know. It really would be ideal if it was like, maybe you shouldn't do this, but being separate systems, I can't really tell what your intent is. But anyway, looks like Melanie's here.
Hey, Melanie.
Hey, everyone.
All right. I only put my name on this so that John would know why it showed up. But I'm figuring Dan, you or Melanie will have concerns to discuss. So
Yeah, I think, didn't I can't remember if I put it on the spec. I thought I just left some comments somewhere now.
I think you have discussed that in the Glance IRC.
Yeah, I thought the spec is not linked from the Etherpad, right? Oh wait, maybe I just clicked on the wrong one.
It is available in the Glance Etherpad, I guess.
The patch is, but
Oh, spec is not there, right?
yeah.
I could only find the what do you call it? The Garrett review for the spec for the Glance one.
You could find it?
I did, but I'm putting it in the Cinder Etherpad, which is probably not ideal.
Can you put it in the chat here, because I don't have to open another one?
Even better, yes.
Anyway.
Okay.
Sorry.
Then I'll just slap I think this is.
Oh, that's the merged. That's old, I think. That's the Victoria one. Anyway.
Okay.
So yeah, I guess I'm not sure, but my concern, I guess, is that I'm not sure why the Glance encryption stuff seems to be not Lux focused, because Nova is only and can only really support Lux as the format for the moment without like having to re-encrypt or convert an image every time we need to use it. And the spec said something similar like about Cinder, which I totally expect. So yeah, I'm just not really sure, why it's written the way it's written, I guess. And I'm wondering how we're going to actually make that work, like from Nova's perspective. So I'm kind of rambling while I'm trying to find the link that I am looking for. But Yeah. So I feel like there's maybe a desire, like the glance work was has a different intent or something. Like from a Nova perspective, we want to be able to download a encrypted image, create an encrypted root disk based on it, and go, and not have to like un-GPG it to a regular file and have it either be unencrypted on disk or have to re-encrypt it, right?
Yeah. Josephine, are you?
Yeah, well, you might notice that the spec is old, and we're trying to bring this upstream for a couple of years right now. And we were talking in Denver, it was Denver, with also Cinder, Nova, Glance, and Barbican, and try to bring all together. And I know that Nova backed out because the ephemeral storage encryption wasn't quite ready or had to be
It's
reworked.
still not, still not quite anything, but
So had nothing to no requirements for us, and you wanted to first do this before coming to us. And I've also told my colleague to come in, but he's AFK. When we were developing this, I don't know if Lux 2 was already there because we wanted to have a re-encryption and not use the same key. And we wanted to have in-flight re-encryption. And that is possible with GPG.
in-flight re-encryption in what?
From the GPG file to a Lux file. So you don't have 3 times the space you have to use, but yeah, that was a little bit complicated. So we chose a more generic approach and try to implement it with drivers so that also later on other encryption types could be added to this. And if you look into the OSBRIC part, that is where the encryption and decryption will happen. We have a spec on it, and this is more driver-like designed. So there's a possibility to add things like.
Okay. But okay. Nova will not be able to use it until it is in Lux format, right? So what about Cinder? I assume Cinder is the same.
And Cinder, we re-encrypt, we decrypt the GPG file and put it directly into an encrypted volume.
And is that because the volume encryption is per backend in such a way that you don't even know what the format is? Meaning, does the 3-par provide an encrypted volume such that you actually need to write unencrypted stuff into it and it just handles the encryption in the back end?
No, we're only really front-end encryption at this point in Cinder.
We're only what?
We're only really using front-end encryption in Cinder at this point.
Okay. So front end meaning the QEMU that's going to consume it is going to be doing its own Lux-based encryption on its end, such that you only ever see encrypted data, yeah? Or the volume does.
Yeah, QEMU or device mapper, depending on how it's.
Well, yeah. That's just the example. So I think that means that consumers of Cinder are like if it's QEMU or device mapper, it's expecting Lux on the disk. So if you get if there's a GPG encrypted image, you have to kind of convert it to Lux format on the disk so that the front end will have a format that it expects, right?
Yeah.
Okay. So I guess I'm not sure why we would really do any of the GPG stuff. Like the reason I can imagine somebody might want to do GPG, and this is why I was wondering if the intent was different, was like I can see, you know, on your local compute or on your local laptop, you've created an image just in a regular QCOW format, and you want to GPG it, and then upload it over Glance to Glance, so that it kind of like is encapsulated and encrypted until Glance then, you know, unpacks it to something that's actually usable somewhere, which would be a Lux format or whatever. But other than that, I'm not really sure that it makes sense to store it in Glance in GPG format when both Nova and Cinder will just have to re-encrypt and convert it in all cases before it can be used. You know what I mean? Like that's a lot of extra CPU. It's more probably storage on disk, at least in the temporary case, and latency for actually booting or getting a volume from it.
So you would move the so you would change it to have, we stream the GPG image to Glance, and then Glance could handle putting it into a Lux container.
I'm not saying we do that. I'm just wondering if that was the intent by the the GPG bit. If you just ignore all the GPG stuff and just say Glance, Nova, and Cinder will all treat Lux as their format, then someone that wants to create it ahead of time can just start QEMU with its encrypted front end, like Nova would, to create the disk in an encrypted format and then upload it that way. I was just trying to theorize why GPG was chosen, because it's not the native format that like either of the other consumers can really use. That was all. So if nobody cares about that workflow, I would say drop the GPG stuff personally. But
I think
so
Marcus is here, so maybe
I asked my colleague Marcus is here, and maybe he remembers a little bit more about why we chose GPG. But he thought it would only start now, the session, because it was scheduled for
he's
this
right.
time.
Yeah. Hi. Sorry. Sorry for the delay. So
The other thing is, if we have different resources with all the same encryption, we always have to copy keys. That's not something from a security perspective I would personally like. So we would have to implement some kind of re-encryption.
We really want to try to avoid re-encrypting stuff.
That's something that just results from it. Maybe Marcus can start now.
Yeah, so I just only joined, but if I get it correctly, you're discussing why we are using GPG, right? Or why we attempt to use GPG and re-encrypt the stuff.
Yeah.
So yeah, the reason behind this, initially our first proof of concept implementation actually used Lux encryption like Cinder volumes do. But the problem is, if you want to provision an image outside of the OpenStack cloud, you need root access, encrypt setup, and the encrypt stuff to actually provision a Lux encrypted file, because you need to open a Lux encrypted container. So we were looking.
It's not true, you know. I mean, that's only if you use dencrypt to do it. There are other ways to do it that wouldn't require it.
Okay. I'm actually not aware of them, so I'd appreciate it.
That's fine. So
share
you just confirmed what I was suspecting, that it was more of an ingest thing than anything else. So I mean, that your workflow or what you're describing is also fine. You can just use QEMU as a regular user or one of QEMU's other tools to create a Lux encrypted disk completely as a user. Nova doesn't use root for that bit of it even. But so if we want to keep that ingest case, we can. personally, like if I was the cloud operator, I would want Glance to image convert that to Lux format on import, so that we don't, so that we take that the performance impact of converting it one time, and then don't take it every single time we boot. Because if you store it in a format that Nova is not going to be able to use directly, or Cinder, every time someone boots from that image, each compute node will have to download that and convert it to the right format before anything can happen. And so, for the same reason that we have image conversion in Glance, it's nice to take that once at ingest time, so that then it can just be quickly used everywhere else, right?
That also has implications for things like setback storage for ephemeral storage, right? Because if we're using a third storage packet, we're going to end up flattening the image every time when we do that conversion.
Yeah. So anyway, I mean, we can certainly keep it. It's just that I would like to see Lux. So no, the current Nova proposal just uses other metadata keys to say, it basically uploads the image as a QCOW file, and then it has another tag elsewhere that says, but by the way, it's actually Lux inside QCOW, and I think that it would be better to have I'm not really sure what the rules are behind container format and disk format, but it seems to me like those are the things that we need to use here for all of these things, right? And not necessarily just go further into all of the metadata, saying this is a QCOW file, and then, oh, by the way, it's also Lux instead. It seems like it would be better to say what it is in the container format. But I don't know, Glance doesn't add container formats very often, so I'm not really sure what the kind of guideline is there. Okay.
Okay, understood. So you're proposing that we use the Lux encryption that is already implemented in Cinder for the images as well, which is already the case if you create an image in Glance from a volume that has a Lux encrypted type, then you already get an encrypted image. This is currently the case, but you are not able to do it the other way, to upload such an image from the outside.
So how does that work? So if Cinder has a Lux encrypted volume and you snapshot it, what does it look like in Glance?
You get the raw Lux blocks there. So if you use OpenStack image create and specify a volume that has an encrypted image, encrypted volume type that uses the Lux encryption, then you get the raw encrypted blocks in the Glance image. If you download the image using the OpenStack image save, and you do a file command on it, you can see it's a Lux encrypted disk. This is already the behavior currently. And what you're proposing is to actually create images that are the same way then. So that, because the images right now, the use case that I described carry some metadata tags in Glance that are called Cinder encryption key ID and Cinder encryption deletion policy, whatever. And I mean, we could simply imitate that. So I recently verified that you can upload a Lux encrypted image again and attach those metadata if you
to get Cinder to do the right thing.
Barbican. If you upload the secret on Barbican beforehand and use its ID to attach these metadata, then you can convince Cinder to actually use this Lux encryption.
Yeah. Well,
but
so I was just going to say Nova's going to do the same thing, but they're going to be different keys. So that's why I think we need to try to standardize on one set of things, because if Nova snapshots an image and it has our flavor of metadata keys on the glance image, then Nova will do the right thing if you download it. But if you use that image to create a volume, Cinder's going to be like, well, I don't see my encryption keys, so I assume it's raw, right? And if they're both Lux, you should be able to create a Nova instance from a Cinder volume snapshot or a Cinder volume from a Nova image snapshot. Right? We just need to make sure that those line up so that we're all using the same method of signaling that this is Lux and here's the secret ID.
Does Nova need to know what's inside the Lux container? So whether it was originally QEMU or it was originally raw or something else?
So I don't think that, Melanie, that you're storing that, are you? Are you using the disk format for raw or QCOW to indicate that?
Sorry, I don't think I understand the question.
Lux can have either raw in it or it can have a QCOW formatted payload inside the Lux thing.
Yeah, I don't think so. I didn't do anything specifically to indicate like a raw or QCOW format. It would just be whatever images type is in Nova.
Right. So that we would set the, I always get these confused, the disk format to either raw or QCOW, depending on whether or not we have it as raw or QCOW on our end.
I think so.
Yeah. So Josephine, I'm not actually sure. Sean might know. I'm not really sure whether the Lux is. I think the Lux is above the QCOW layer, right? So it's actually the.
No. I don't think so. I think it's inside of QCOW too.
That's what I mean. So if you do a file on it, the file will think that it's a QCOW file, but you have to interpret the logical disk blocks as Lux, right?
Yeah.
Yeah, that's what I mean. So the reason I say that is that, you know, it seems like maybe using container format for Lux would make sense, but that's not actually right, because the Lux is sitting on top of the QCOW bit. It's like the next layer up from disk format.
Yeah, I think currently the main thing that distinguishes it as QCOW2 encrypted is the fact that it's QCOW2, but that it also has the Barbican key associated with it.
Yeah, yeah. So Josephine, I think that the answer to your question is that Nova will look at the disk format and set the disk format the same way it would whether it was encrypted or not encrypted, and that's how we know or care if we do whether it's raw or QCOW. And I guess that also means that using container format to communicate any of this is not right. So either we would need to have another disk format of QCOW plus Lux, which probably isn't right either, or we just use one of these metadata keys to say that, yeah, it's QCOW, but interpret the contents as Lux. But that's different than GPG, right? If you're GPGing it, you're GPGing a QCOW or a raw that above it has, you know, just disk blocks and not an extra layer.
Okay, so let me just recap that. So if we go away from the GPG approach and we would go towards using the Lux encryption, then we need a new approach on the client side to use QEMU tools or something. if we want the user to have the opportunity to upload image in encrypted format. So on the client side, we need some tooling that can turn regular images like RAW or QCOW2 on the client side into LUX files. And
If you, so just to make it clear, if you have a regular QCOW already, you can do QEMU image convert and some command line things and change it from a regular QCOW file to a QCOW file with LUX above it. It's just a regular user command.
Okay, and this would be a format that also Cinder would then accept?
That's the same, that should be the same format that Cinder is currently using and the format that Nova is using.
Okay. So if you have a LUX disk with a QCOW format in it, Cinder or Nova is able to boot it as a volume?
It's the other way around. It's the other way around. You have a QCOW file with LUX as an extra layer sitting on top of the QCOW-ness, right? So LUX thinks it has a full disk, a non-cow disk, because it's virtually mapped, but the QCOW, sparseness is sitting below it, just like normal. But yes, Nova, if you tell Nova that it's LUX in there after the set merges, then it will tell QEMU that the layer above QCOW is not raw disks, but is LUX, and QEMU will do the decryption for you so that the guest just sees a disk and doesn't know any different. And I believe, based on what Eric was saying, that that's probably what you guys are doing in Cinder as well, or that's the same orientation of things.
I was under the impression that Cinder only handles raw block devices and with nothing between the raw block device and the LUX encryption layer. But feel free to enlighten me on that.
Well, in the raw case, it will be, that is how it will be. Like if you do, you can also do that with QEMU. You can convert your QCOW disk to a raw disk, which just flattens it out. And you can also convert it from a QCOW disk to a raw plus LUX, which just does a one-to-one mapping of all of the blocks, but with LUX encryption sitting above it.
Yeah, and I mean, if the image was consumed by Cinder, would Cinder convert this QCOW stuff?
Yeah, that's a good question I also have.
I mean, I'm not aware of any QCOW support in Cinder volumes directly.
So if you have an image in Glance that is QCOW format and you try to create a volume from it, what does Cinder do?
It converts it into RAW.
It converts it to RAW. Okay.
This is what I was referring to. This is the same. Sorry.
I was saying this. We can create QCOW2 volumes on the Cinder side actually, in NFS backend, but I don't know if
we only do it for NFS. It's kind of a special driver case currently.
You only have QCOW as the backing, you mean? But if you have a 3-par or something and you try to create a volume from a QCOW image, will you flatten it out onto that volume?
Yeah.
Yes. Okay. Yeah. So I mean, it's basically the same thing that Nova does, right? Like the source of the image and how you have your storage in Nova configured can be different. And if we need to turn it from QCOW into RAW, because that's what you have your compute node configured for, that's what we do. And if you have your image in QCOW format and your compute node set to use QCOW for the space savings, then we just download it and use that as the backing file or whatever. So again, I'm not trying to say that we shouldn't allow GPG as a method for ingest. I just don't think that we should expect that everybody's going, I mean, clearly Cinder is not storing currently them in GPG format, right? But like it's just not good for Nova or Cinder's workflow to have to always convert that thing. And so what I would rather do is kind of make Lux the standard or the intended cold format. And if we support GPG as a method for people to get their encrypted image into Glance and convert it later, then that's fine. But I'm not sure that there's really a need for that, given that QEMU image convert can do that for you, put it in the right format natively without any root or special access needed, or it works on a Windows machine even.
So I feel like we had this same discussion a few years ago about this feature, and I'm trying to remember why at that time we thought the GPG scenario made sense, and I don't really recall, because I'm pretty sure we had the same thought a while back.
Well, I'm wondering if it was because back then, or maybe just the people at the time thought the only way to create a Lux thing was with device mapper, which might have been.
Yeah, this is exactly the case from my point of view, because Josephine and we were driving this forward for years now, and the information that we could use QEMU convert tools without root access to create those is new to us. So this changes a lot, and I can totally see your point about this, and it would really pull out a lot of complexity also from the patch set if we were to simply reuse what the current Lux handling actually does. So we would gain a lot of simplicity if we were to actually restructure the whole patch set to reuse the stuff. What I'm currently thinking about is that we lose one functionality that we would currently introduce with the GPG-based approach, and that is creating encrypted images from unencrypted volumes. So,
okay, well, so yeah, so one thing I was going to say was that I think that if we standardize, that Lux is going to be the format, then I don't actually think that Glance has to do anything. It's more that Cinder and Nova should be using the same metadata keys so that we're all, we're storing the secret and the format in the same way so that we both will interpret the right thing. Technically, Glance doesn't need to do anything in that case because Glance doesn't have to care, right? It's just storing the encrypted disk and it's exposing it. If you want to allow Glance to say, like an operator to say, I want all of my images to be encrypted. So if anyone uploads an unencrypted disk, I want you to, encrypt it, create a key, store it on the image, and actually have the image be encrypted on disk. Then that would be, some Glance functionality that that would need to be added, and use the same metadata keys for all of that stuff as well. And that, you were saying create an encrypted volume or create an encrypted image from a volume. That would be one way to do that. Nova is going to make it so that if you have an unencrypted image and you go to snapshot, you can say, but I want the snapshot to be encrypted, and then Nova will just do that part as it's creating the image and upload it pre-encrypted, which of course Cinder could do as well, but Glance could do that in its import case. It can't do that in its upload case, so that might be a good reason not to bother. But
okay, one thing you mentioned about the metadata keys would currently be problematic, because currently if you create an image from an encrypted volume, the metadata keys are prefixed with Cinder,
right.
Cinder encryption key ID, and so on.
Yeah.
So maybe as part of the image encryption going forward, we could try to get this in line with all the perspectives on it.
Right. I think that's the work that would need to be done. So, we could just say, well, Cinder was first, so we'll all use Cinder. I think that's probably as the prefix. I mean, that would probably be confusing for users who want to go upload their thing to Glance they might not even have Cinder in their deployment and have to prefix them with Cinder. I think it would probably be better if we can to come up with some standard generic neutral Switzerland key that just implies that this is an encrypted image, and then have Cinder basically use that for new stuff and continue to honor the old one where possible, and then we'll just change the Nova patch series to use the standard key from the get-go because it's not landed yet, right? So I know that kind of is unfortunate for Cinder, but that would probably be the way I would suggest.
Wouldn't that be a good point actually to really introduce a new container format in Glance that really differentiates, so that you can say, okay, container format is encrypted and this is the new format shared by all components?
I would like it, although I think it's technically wrong because the container format is not LUKS. LUKS sits above the disk format even. Like if you think of these as layers, container format is like the bottom layer, QCOW is the middle layer, and then LUKS or nothing is at the top layer. And so you've got container format, disk format, and then we don't have a thing for that for the third layer. So we could add that formally in Glance, which would be fine with me if the Glance people want to do that.
Well,
I'm just not sure that container format is the right terminology.
The proposal, I just put a link in the chat. I'm not sure which Etherpad it makes sense to put this stuff in, right? So the proposal was to add an encrypted format, container format to Glance. And then it was going to have a whole bunch of metadata values associated with it that would indicate exactly what was in there. So
Yeah.
we could still go with that.
We could, although I'm not sure that works because the OS_Glance prefix is read-only from users, and so Nova and Cinder would need to be able to set those things. So yeah, container format of encrypted is nice. I just think that it's wrong because it's not the container format. It's like above the disk format layer-wise. If we want to say that doesn't matter, then that's cool. I'm not sure that it's, like container format is supposed to be, is this zipped or not? But then the next thing is, what's the actual format of the image, QCOW, and then what we're talking about is a thing on top of it. And the problem is that GPG is actually the opposite. GPG would be the container format. So that it makes sense for the GPG case. It doesn't, I think, for the LUKS case. So, whatever, I'm not all that opinionated. I just want to make sure that if we're choosing container format, we realize that it's wrong. It does seem like a good cubby to put the thing that we want, though. So. Dan thinks it's not. Yes, absolutely. I'm the only one.
Yeah, I can do that part, but
No, it's fine. I mean, I don't, but I'm also not saying that we shouldn't do it because of that. I'm just saying it. I just want to make sure that we are cognizant of what we're doing. But regardless, I think that what we're describing is that the Glance effort here becomes a standardization of the keys and the communication, so that Cinder and Nova are doing the right thing. And that's kind of the first step, right? And then the second step, optionally, if we want, could be adding an image conversion plugin that also will encrypt images if they're imported unencrypted, right?
So,
Sorry.
no, go ahead.
if you go back to the linked proposal, I guess we could push for these metadata attributes OS_encrypt to become kind of the new standard. Maybe also having some of these as placeholders for future extensions or whatever.
We can. It's just that Glance does not allow you to set those through the API.
You can.
We already have OS_hidden parameter. What you're talking, we kept reserve some parameters which starts with OS_glance.
Yeah,
That's it.
these don't start with OS_glance, just OS_, and this should be possible. I think we tried that.
The proposed change says OS_glance_encrypt_format.
Okay, where does it? I have the link open and it doesn't say for me. So, and
I'm looking at the Victoria one. Maybe it's.
Oh, maybe.
Oh, okay. The Z one's different. Okay, I got it.
Oh, okay, yeah.
Sorry.
This was an old version because of exactly this point we changed from OS_glance to OS just as a prefix, and this would solve the mutability issue.
Yes. So yep. I think that those keys as the default make sense. I don't know that all of them
so
necessarily apply, but yeah, let's. So the point is, we'll re-swizzle the spec to basically be a definition of the standard keys to use for encrypted images, right?
Yeah, and then we would need to apply this to the existing cases, like images created from encrypted volumes, as well as the new Nova stuff, and later on stuff that users upload in an encrypted form.
Well, in that case, in the upload, so yes, I agree on the Cinder and the Nova case. On the upload case, the users would just set this as properties when they're doing their image create and their upload, right?
Yeah, exactly.
Okay.
But
yeah.
it would be great to have this kind of automated in the OpenStack client.
Oh, to look at the file that's being uploaded and say.
No, not particularly looking at, but providing at least the command line option to say, okay, this is encrypted. Please specify these parameters. And what we currently did was to actually wrap the GPG calls into the image create command, so that the OpenStack client is able to encrypt the raw image for you, and then upload it by also creating a Barbican key and using this for encryption completely transparently, so that you don't have to handle the Barbican key and key ID. Would be great if we could come up with an alternative for the QEMU tools to do this as well, so that OpenStack image create requests a Barbican key, does the encryption using the QEMU tools for you, and then uploads the image with the appropriate key ID to Glance, so that you don't have to fiddle with the Barbican key stuff on the user side.
Okay, I don't know what the OpenStack client team's view on that scope is, whether they want that kind of stuff in OpenStack client or not. So that if they do, then that's fine. At the very least, I can see it making it useful to say, here's an encrypted QCOW and here's the secret for the disk, and have the OpenStack client create a Barbican secret, put that in there, and then use that to set the OS encrypt key ID for you. But yeah, anyway, I'm happy. I mean, I'm like I say, I'm not opinionated on the OpenStack client bit, but that would be cool.
Okay, so I may have a stupid question. You were talking about image conversion. Okay, so ideally we use image conversion if SEP store is configured to convert it from QCOW to RAW. So don't we need to enhance the conversion plugin for this purpose?
No, not necessarily. So if you've got a encrypted QCOW and you import it to Glance, and Glance needs to convert it to lay it down as raw on your Ceph image, it will end up in raw Lux format by the virtue of taking the QCOW-ness out of it, and then it will work just like a Lux raw image.
Okay.
So it won't. The only thing that we'll need to change, sorry, maybe this is what you meant, is that in order to do that encryption,
Right.
actually, I'm not sure. Melanie, if you convert from QCOW Lux to Lux, do you need to give it the key? You shouldn't really have to, actually.
You do.
Maybe it has to re-encrypt the empty space or something. But technically, I mean, I'm not sure that why you should, because you're just laying the blocks back on there. But anyway, so
I think it might re-encrypt the keys in the Lux headers because the headers might actually be stored differently. But yeah, I don't know.
I'm not sure that they are, because I'm not sure. I mean, the Lux doesn't know anything about the QCOW that I know of. But regardless, so yeah, if the conversion command requires that, then Abby will just have to make that stuff say if that key is, or if the property on the image is set, then we just grab that key ID and grab the secret and pass it to the QEMU image convert that we're already running. But it's not fundamentally a different thing.
Okay. Thank you.
The only thing I see is so the current handling for encrypted volumes is sort of envisioned as like a closed system, so that Cinder encrypts the volume, it can convert it to an image, and then it can convert images that it has encrypted back into volumes. Because we handle the key in a particular way. So we don't use the key directly. What we do is we take, it's like basically we ask Barbican to store a 256-bit, payload. And then we ask them to stream it to us as an octet byte stream. And then we convert what we actually use to pass to Lux to open the container is that value converted into hexadecimal digits, and we pass it to characters. Yeah, so it's perfectly acceptable and a normal thing to do, but it's not like you can just take any key in Barbican and create a Lux container and then expect Cinder to open it. So so if we do allow outside stuff to come into the Cinder closed workflow, then we just need to be careful about how that's handled.
Okay, so we could do this a couple of different ways. One, we can describe how that works in the documentation and tell users that's what needs to happen and let OSC do that encoding for them, and then just make the Nova side do the same thing. Or we can say that Cinder will do it not that way for keys that are the new key, the standardized key.
So I don't think we want to do that, because the other problem is with Barbican is you've got there's like a lot of complications for how stuff's actually stored in there. And if you start to go between clouds or different Barbicans, all sorts of crap can happen. So I think we want to kind of stick to what we're doing, where we just say Barbican, stream us the bits, and then we'll take it from here.
You're saying that it's a non-ASCII printable 256-bit value, right? Stored in Barbican.
Yeah, roughly. I mean, all right. So my experiments with this are maybe 2 years old, but I had a lot of trouble getting a key into Barbican that I could get back out and use. And finally, what I wound up doing was just say, have Barbican create it, and then use that. So what I would do, what I think we want to do is have Barbican create the key however it wants. And then when we go to encrypt, you just ask Barbican to stream it to you as a bit sequence. And then we just interpret it to encrypt or decrypt the way we do now.
So
it's a good point, because it's just using regular command line stuff to manually store keys in Barbican and use them. It's really easy to mess up, and you have to have a very specific recipe for it to work.
You're using you said command line. You're using the key library, right?
Well, we haven't gotten to that part of this discussion yet, where if they're going to put an image in there with a key, somebody has to put the key in Barbican. And I'm
Yeah,
not
I
sure.
think what we want to do is just have Barbican create the secret. So you never, because you got to trust Barbican, for this to work at all. So I can imagine people might want their own keys, but I think it's hard to make that work in a way that actually works. So.
I guess I'm not sure. Melanie, you're using, you're generating a passphrase type thing, right?
Yeah, it uses like a random function to create one.
Yeah, so sorry, go ahead.
Maybe I can shed some light on that, because I incidentally had this tried this last week. So what actually happens is that a secret order is created in Barbican, so that Barbican is instructed to generate a random key. This is kind of binary payload.
Mm-hmm.
And then the function that I posted in the chat, the bin ASCII hexlify in Python, is used to convert this binary format into ASCII characters. These ASCII characters are then used as the passphrase to the LUKS encryption to create and unlock the encrypted volume. So, and this is what I also referred to in terms of abstracting this in the OpenStack client, so that users don't have to fiddle with the keys, because this is what they actually would need to do, but the client could do this for them to instruct Barbican to make a key, to convert it to ASCII, pass this to the QEMU tools, and then attach the key ID to the image, and everything is working just like the currently closed cycle in Cinder works.
Yeah. So the problem is that, and Brian, maybe this is the struggle, is that LUKS is intended to use a passphrase. It has its own binary key that it encrypts the disk with, but it's expected that you provided a passphrase, not a binary value, because it's intended to ask you for a password while you're booting your laptop, kind of a thing.
But from my understanding, what gets stored into Barbican is not necessarily, it just stores bits, and then you interpret them in the way you want. And so it's really important that...
Yep, right, but you can store a string there, which is the passphrase.
But it always gets passed through the bin ASCII hexlify method. So even if you
in Cinder
store a
yeah, I understand. What I'm saying is, I feel like Cinder is storing binary data, but it's having to generate a passphrase, because that's what all of the QEMU and LUKS tooling requires. So the fact that you're storing it in binary in Barbican is fine. It's just not what everything else requires. So you're kind of it's like you're storing the passphrase in EBCDIC, but you have to convert it to ASCII in order to actually be used, because all of the tools below it use ASCII. And so what I'm saying is, I think that what would have been the right thing to do is for you to generate your binary key, if that's what you want to do, hexlify it, and then store the hexlified version in Barbican, because that's what the users are expecting and what all of the LUKS tooling expects, which is a ASCII or Unicode or whatever passphrase. It's not a key, it's a passphrase.
Yeah, the reason behind this was simply because if you instruct Barbican to generate stuff for you, it generates binary random data. So it's I think it wasn't Cinder's decision to make binary keys. It was the limitation that you couldn't instruct Barbican to make to generate something like a passphrase, like something that can be interpreted as ASCII. So they simply shipped around this limitation by using the Barbican functionality and converting it.
Yeah, and it's not wrong. It's just kind of wrong because it's like
Well, it's because it's
saying
random fill, right? We just want a random fill of bits, and so that's
right.
And we didn't
then-
want to have to try to code that ourselves. So
Yeah.
since Barbican can do that very well, we let it do it.
That's fine. It's just that that's
yeah.
not the data that you have to provide to Lux. So you chose to interpret that in a particular way, but it's not like it's not what Lux actually. It's not what users. If I go and create an encrypted.
Well, I know that's why I brought it up, because right, if you just use Lux in the way you expect it to work, you're going to encrypt something that it's possible Cinder won't be able to decrypt.
Right.
Right. So
That's a good point, actually. I mean, we could try to support this with the new metadata values to indicate whether the key is binary or the key is already the resulting passphrase.
Yeah.
Then we could support a more expectable behavior for users.
So do you mean make the new ones only use passphrase, or add another key that says how it's encoded?
I mean, we can discuss that in favor of Cinder not having to change the implementation. We could go for an approach that allows both to work.
Well, I mean, yeah,
I have no preference on that.
I guess it seems to me like unless we think that there is a specific need for storing it, you know, like if we were using something other than Lux, then I would say, yeah, we need to basically support the encoding in a particular way. But like Lux is passphrase. So to me, it would be better to make the new keys, like if Cinder is going to go create a volume from an image, it looks to see if the new metadata format is there, and if it is, it assumes that the key in Barbican is a passphrase, and if it's not, then it falls back to the old Cinder _ way, and if that's there, then it's like cool, but that's binary and I need to hexlify it. You know what I mean? If we don't want to do that, then we can just have an OS encrypt key encoding, either be hex or passphrase or whatever, but then everybody kind of needs to implement all of those different ways. But
yeah, one thing to maybe also think about is what the implication of this would be regarding key length and entropy here. I mean, it's already complex because the secret generated in Barbican is not used as is, but passes through the key derivation function in Lux and so on. But I mean, the current approach in Barbican is to specify a key length or a bit length, so to speak, and then you rely on the backend in Barbican to actually generate this with a sane entropy. And if you use HSMs or something in Barbican, then you have some kind of guarantee about the randomness and the entropy.
Yeah, that's why I like the idea that we have Barbican supply the secret.
Well,
yeah, this is. I mean, if you have binary, then you have the full set of bits and bytes that you can handle, and you can actually make use of this entropy. If you limit the set to ASCII characters, then you have another discussion about entropy and randomness. I don't know if we actually want to open that kind of worms.
Yep, sure, but I mean, all I'm saying is that the tooling below it all requires ASCII. So you're either doubling the length of the key and hexifying it, or you're or not, right? So I don't. All I'm saying is that the tooling below requires a passphrase, and users, if they're going to be able to interact with this, need to be able to provide a passphrase, and so I'm not really sure. Like if I've created my passphrase or my disk with a passphrase of foo, and I give that to you, and you're like, well, that's cool, but like I need a 256-bit binary value in hex. Foo is not that, so you're going to have to like take the huge CPU hit to re-encrypt that image, or at least redo the Lux header to change that. And I guess I'm just not sure like that's a very user focused, like the tooling is passphrase, you know?
Yeah, I mean, you could unhexlify the actual passphrase and put it in Barbican. You could
can't
revert the
unhexlify foo.
process.
You can't
Yeah.
unhexlify foo.
You could prepare the secret in a way that the current workflow understands it and processes it correctly. I mean, it's wouldn't be a beautiful solution, but it could work. And also, I don't want to say that not relying on the Barbican entropy and the key length and whatever is making things worse here, because you have the key derivation function in Lux, and Lux also is based on passphrases, as you said. I'm not claiming that we are losing anything in the security perspective. It's just I cannot say for sure what the implications are there. This needs to be looked at, and I don't feel confident to make the last words in terms of security there. So I just wanted to bring it up.
Yeah, well, we don't have to decide it here either, right?
Yeah,
we can go off and look. I'm just I would like to have fewer. I would like to have fewer options for this, meaning like everybody that implements this not needing to support multiple ways for, you know, the key to be encoded for this particular reason, and also that we not tell users like, well, sorry, you can't upload that image because you chose a passphrase that isn't all hex, and that's not how we roll. I would have to go look.
On the other hand, right, you would have something like your password's too short. You need to put in one of these characters. You need to not duplicate your username, all that kind of stuff. I think it's just easier to just say Barbican creates it, and that's the way it goes.
But then I can't create an image outside.
Well, you can. You just have to download, right? You just have to stream it. You have to do what Cinder does, right? You stream the output. You ask for Barbican to provide the key. You give it the application octet stream as the content type, and then you just hexify it.
Yeah, but that means that I have to have done that before I created my image, right? Or I have to reconvert my image. So Lux, I mean, the whole point of Lux is to make this not as big of a deal, which is why, as you say, it doesn't actually use the passphrase to encrypt the blocks. So what I don't know, like Lux also is supposed to allow you to change the passphrase, right? But I'm not sure that we have the tooling to actually do that without literally re-encrypting terabytes of image data. So I can go and look, but
well, we do, because we do it in Cinder currently. But there's a big gap there because it's in the crypt setup tooling, but it's not in the QEMU tooling.
Right, that's what I mean. I know that that's what it's for, but I just am not sure that we have the ability to unexpensively make that change.
So I'm not sure what the way to go forward is here, because I'm totally with you to keep things simple and not introduce I don't know how many ways to do it. But if we go the route to say, okay, we handle passphrases as passphrases, we need a new source of key generation in Cinder to be in line with the new behavior, so that Cinder don't use sexified stuff, but actually stores passphrases in Barbican. But Barbican is currently not able to generate ASCII compatible passphrases for you. So we would need to do this in Cinder. The other choice would be to put this on the user side, so they use or convert their Lux passphrases into the binary form that would be required. So to speak, unhexlify the stuff before putting it in Barbican or whatever. So either way, we would have to make, we would have to work around the stuff if we don't want to keep maintaining two ways to do it.
Well, I think it makes sense to start out doing it the way Cinder does it, so that we don't have to change anything, and then we can always extend it to handle the ASCII keys later if there's demand, if people actually are using this feature in such a way that they want to take old Lux containers and stick them into Glance. without changing the passphrase to meet our standards. All right, so I think we treat this as a documentation issue for now, and get the rest of it working, and then we can come back and change this if we need to enhance it.
Okay, so you are favoring keeping the Hexlify stuff and putting the burden on, or burden is maybe a bad word, putting the effort on integrating this properly on the user side, so that either documentation or automation in the OpenStack client takes care of preparing the passphrase correctly to put it in Barbican, either by having Barbican generated for you, or for the OpenStack client, for instance, to convert it, unhexlify, so to speak, before putting it into Barbican so that it works in Cinder later on.
That's my preference, but I mean, I'm just one guy.
Yeah, it's not my preference, but I don't, I mean, whatever. I'm just looking through the Barbican secret API has like encoding mechanisms and whatnot. So I was just looking to see, make sure that our
all I know is I was looking at this about 2 years ago, and I finally went to the Barbican people and said, look, I can't get this reliably to work. How do I convert this? And they just said, don't.
Well, so they have a secret type of passphrase. So what I'm wondering is, if you do a generate and you say secret type is passphrase, if they're going to generate you, a passphrase.
Yeah, I was about to say something similar, that I'm not sure how this works with the secret types that it has.
Yeah.
Yes, I don't believe it. Barbican will not generate a passphrase.
No, as far as I recall, most of this stuff like algorithm mode and also secret type like symmetric or passphrase is not actually evaluated by Barbican that much. It actually acts more like metadata so that users can recognize keys and can categorize them, but Barbican does not enforce this on secrets uploaded or generated by it. So, but this brings up a new idea in my head. If we use this in the Barbican secret metadata, we could differentiate. If we see the secret type is symmetric, we use the hexlify to process it. If we see the secret type passphrase, we skip the hexlifying and use it as is. Then we could support it based on the Barbican metadata, both cases.
Yeah, it just means that it's the same thing as what I was saying before, which is that everybody that implements it has to be able to support it that way. And it's weird because Lux only has passphrase, so you would kind of from the outside expect that like the key type, the secret type has to be passphrase for something that expects a passphrase. Addy, I didn't realize you were here. I'm glad you were the person I was going to go blind to. But so do you have I'm not sure how much of this you've been listening to. All of it?
Yeah, most of it. Yep.
You just decided to just swoop in at the end after we've
pretty much. Well, yeah, no. So I mean, Barbican does not generate passphrases, right? So Barbican, if you put in an order for something in Barbican, it's going to generate it'll generate a key basically. It's only used for generating keys, and it uses whatever is in the HSM.
Yep.
In order to be able to do that, or it uses basically something like urandom or something like that if you don't have an HSM. It does not have something that generates passphrases. It is something that we could potentially look at if this is something that you guys would be interested in. We would have to look and see what that means in terms of HSMs and so on and so forth. Yeah.
Do you I guess just what's your opinion on the, like, or maybe you don't have one, but the user showing up with a perfectly legit encrypted QCal Lux file with a passphrase, but they can't like ingest it into the system like they would expect. And or I guess what's the security read on Nova generating passphrases that actually just get used, you know, hashed and revolved and whatever into the actual key that the Lux file uses? Like, should we definitely be having Barbican generate these things for us?
Well, I mean,
I'm trying. Good.
Go ahead.
Sorry. I was just saying, I'm trying to, you know, like approach this from the user perspective, where a completely legitimate Lux encrypted with a Lux compatible passphrase thing is what we claim we are supporting, but we don't actually, because we have this other kind of weird requirement for how the passphrase has to be.
But we're not claiming we support that, right? We're deciding what we're going to claim we support.
Right.
Right. So we don't want to support having really weak passwords for your Lux container.
But,
right. Even if right.
Yeah, I mean that's fine, but that's like a different policy than like it has to be hex encoded to me, and it has to be hex encoded of exactly one particular length, right? Because you guys are doing a 256-bit key and then generating a 256 or a fixed length hex of that particular key.
No, it's just got to be a right. It's just got to have the right. It's just got to have the right boundaries, right? So as long as you can break it into bytes, we don't care.
Meaning you'll unhexlify it and use it whatever length the actual result is. Not.
No, it's got to be right. So we can pass it something else, I believe. But I think I mean my perspective is just, look, if you're interested, right? I don't think this is like a feature for dilettantes. It's like if you're really interested in having your stuff encrypted in a strong way, then you're probably going to want to do it in a strong way and not have a password of foo, right? So
yeah, but like
the way we do this is we have Barbican creates, right? It's set up to create a random fill that we can use, and then that's what we do. And then if you want to do it too, we tell you how to do it. But
yeah, but like I'm not sure how many people download images of their volumes and use them locally, but like that's a thing, a very common thing in Nova, right? And so like you end up having to download this thing that was created in, I mean, it's I don't know. There's more than just the security aspect of the user experience, I guess, is what I'm trying to get at. And you may not want to expose like Lux compatibility, but like I think we do, especially if we're going to call it Lux, because users take stuff in and out of Nova, I think, more than probably terabytes of data and a volume. But I don't know.
So is Nova supporting Lux 2 yet, or are we still just Lux 1?
Lux 1.
Okay.
Yeah, there's QEMU limitations, I think.
Okay.
Yeah, I think QEMU can only do it for RBD or something like that.
Okay.
Yeah, we have some Lux support in OS Brick, I think, already, but it's not fully there everywhere else.
So Addy never, like, I cut him off and he never responded. Do you have opinions here or no?
I mean, I sort of do and I sort of don't. From a Barbican point of view, right? I mean, we're Cinder's sort of saying to us, give us a key, and we give you a nice strong key, and then what you guys do with that key afterwards, is kind of up to you, right? So, it's Barbican is going to, we're essentially going to create whatever secret you want and deliver it there. And if it makes sense to what we're talking about here is really sort of a tooling problem after it gets out of Barbican, right? It's how do we make it such that it's easiest for a user to put
Interact
in
with
a
it. Yeah.
secret, interact with say Barbican in such a way that makes it easy, right? And maybe what we're talking about here is a change in Barbican client or something like that to take what would be a passphrase and turn it into something that's the right way.
So
that
yeah.
might be one approach of taking this is if we want to use to take a hex, you take a passphrase and turn it into something that Cinder can then use later. That maybe we have some sort of way in the Barbican client thing, some sort of update, to Barbican client, whereby we could say, here's a passphrase that's supposed to be used by a Cinder thing. You're going to get a secret ID that is going to be a hex key in the appropriate way that Cinder wants to use it, and that's what we use, or something like that.
Well, I'm not sure that Barbican needs to know or care about this like scheme of doing things. I guess the thing that would be nice is if it would just generate a passphrase with a particular length as a thing, and then maybe that would be, that then it can do it as securely as it wants to do, or whatever. But would it? I assume that the key generation is part of the secret generation, right? You say, give me a secret. I don't have a value yet. Generate me one, and then it just returns the secret pre-populated with something, right? It's not like it's two separate APIs.
Right.
Like generate.
Right.
Yeah.
Well, there's something cool. It's an order basically that's created. So you create an order, and in the order you basically say, give me a key of length X, whatever X is, and I think there's a couple of other algorithm things and so on in there, but basically create that key, and
but it ends up in a secret.
It
right?
turns into a secret. That's right.
Yeah.
And so you end up with an order ID, and the order ID ultimately is fulfilled with a secret once that secret is generated.
So I guess the thing, like the user experience thing that I expect the sucking, and I guess Brian will say, well, they should have read the docs, so fine. But like I've spent a week creating my image, and I've got it encrypted in a particular way, and I'm ready to go upload it. So I go and I upload it to Glance, and I set that it's encrypted, and here's the key, and I've put the key in Barbican as a passphrase because it is a passphrase everywhere. And then I go and finish that whole upload thing of a terabyte, and then I go and create an instance in Nova, and either Nova does all of the work that it does to boot an instance and then fails in some way that says, well, the key doesn't look right, or the passphrase doesn't look right, or it assumes that it's a passphrase because it is, and it boots the image at the instance, but it can't access the disk because it can't decrypt the data. Like, that's several steps and many terabytes of transfer down the road before you'd be like, I don't get it. What's the problem? And then you go read and like, well, it's a passphrase, but it has to be special, Like, that's the kind of relatively expensive way to figure out that we have extra rules on the thing. To me, like, if we're going to enforce length and complexity requirements on a passphrase, it would be ideal if that was a Barbican requirement, where I went to go create the passphrase in Barbican, and it's like, sorry, system-wide policy says it has to be at least this long or whatever, and then I know about it immediately, right? And then once I got the passphrase into Barbican, then later I find out, well, Lux uses a passphrase, but Nova doesn't use a passphrase because we require the passphrase to be encoded in this other way. You know what I mean? Like that's expensive and painful for the users. That's what I'm
that's
trying
why I
to
think
avoid.
what most people are going to do, right, is you just ask Cinder to create a bootable volume for you. You go in there, you do whatever you need to do, right?
That's not the workflow that I would. I can't do that on my laptop for a week before I go and upload it to the cloud. I can't like start with a Cinder volume, right? I start with an image. Like that's the.
I don't know, but if you want anything to work, right? Usually it's better to work like in the cloud so that you know it's going to actually work before you stamp out 500 VMs based on this image and find out that none of them can do what you need to do. I don't know. I mean, we're getting kind of off track. My feeling is just we've got a good way to do it right now. We should probably stick with that and then enhance it later if there's a demand. But, you know, like I said, I'm just one guy.
Maybe we should also, I mean, Melanie was kind enough to write in the chat what Nova is doing, and they are using the passphrase secret type, which Cinder doesn't. Cinder uses symmetric, and this indicates the keys that are used for LUKS encryption and must be hexlified. So wouldn't this also be great to get in line with Nova then, and maybe support the passphrase secret type for this, as I stated earlier, so that we make the distinction about the behavior based on the secret type?
Yeah, I mean, it is a passphrase. That's why we're using passphrase.
And Cinder doesn't, and this could still indicate the old behavior and would be backwards compatible. And using passphrase as a secret type in Barbican indicates the new behavior. And
I guess that's what we need. I mean, if Cinder's willing to do both, then I guess that's the compromise, is just do both.
I don't have the Cinder implementation right now before my eyes, so I cannot judge if at the point we are hexlifying the stuff, we still have easy access to the secret metadata, or if this would be a bigger architectural change in Cinder. This is what I cannot judge right now. But if we still had easy access to the secret metadata, we could easily switch behaviors in Cinder at the point where the secret is computed. Brian, would you be fine with that?
Yeah, well, I think this is probably more of an error question, actually. But I think what we will still want to use the way we're doing now, because we're generating lots and lots of secrets in Barbican. So I don't think we want to go to passphrase. I think we want to just let Barbican do the random fill that we need, and then we go from there. I'm not.
So it sounds like no compromise. So we'll just, I guess, implement them in both formats in Nova, and I don't know how Melanie feels about that, but I guess that's the only way that we're going to be interoperable. So I'm actually late for another thing. Late,
I'm willing to compromise, but I want to keep the way we've got now because I think it's stronger. Right. So I view it as a pure user thing that we allow the passphrase to be used. I think it's stronger to just have Barbican generate the secret that we use, because we're generating so many of these freaking things. So might as well. But you know, so I would not want to switch over and have like a deprecation period. I would want to keep what we've got.
Yeah, I wasn't actually proposing to change this part of the behavior. I was only talking about bringing user-created images into this ecosystem so that users can decide, okay, I set the secret type to passphrase and trigger a new behavior in Cinder. But if Cinder ever creates a volume by itself that is encrypted, it still uses the old way of getting the key created by Barbican, using the secret type symmetric and hexlifying the stuff. But if users bring in images with existing passphrases, they can mark it with this passphrase secret type, and Cinder would then be compatible to compute it. And as a bonus, it would be able to compute images that come from Nova potentially, if Nova uses also the passphrase secret type. Because as I understand now, if Nova uses it like that, then Cinder couldn't, because it always forcibly hexlifies these things and doesn't expect passphrases to be there. I mean, yeah, it would be some kind of mix and match and not the ideal world where everything behaves and acts the same. But if we want to compromise on making the least architectural changes at all sides, then maybe we need some kind of middle ground where we can meet and can handle both formats, both ways.
Yeah, it seems like if we have a way to mark the key so we know what it is, and it looks like, right, the secret type is what we would use. I'm not sure with the current code either, whether we'd have access to that at the point we do the hexlification.
If you've gotten the secret from Barbican, then you're going to know, you'll have the secret metadata that's there. So you'll know all of that that's in the metadata.
I'm just currently looking up the code. I've just found the RBD code for the Ceph backend, and the hexlify happens immediately after pulling the key from Barbican using Barbican's API. So the metadata should be at the same place where the hexlify happens. I mean, I would still need to verify if this is true for all backends where the hexlify works or is used, but judging from the RBD driver as an example, it would work because it's the same place. And we
So
have...
the question was whether you could get it what metadata when you're doing that.
Pardon?
So there's metadata about the secret, right? And I don't know whether or not you need to have a second. There's a call which you make to get the secret, and that gets just the information about the metadata of the secret, and then there's a call to get the payload. And there are two different calls within Barbican. One will get you just the payload, and the other one will get you the metadata that's there. So you may need both. I don't know what you guys currently do. I guess we'll take a look.
Well, I was asking what's the metadata we're trying to get at or update exactly. I lost track of that part.
It's the metadata attribute called secret type of the Barbican secret, and we only need to read it at this point where we need to call the hexlify or not. We just need to read the metadata attribute secret type and decide if we need to hexlify the received secret payload or not. This would be the proposed solution.
Yeah, I mean, currently all we do is we do a get and then use the key from inside of that. So if
so the get is going to get you all of the metadata, which should include, secret type, and then what you're doing was when you're doing the get encoded, which is the second one over there, is you're actually just getting the payload, which is what you'd expect there. So you are actually making two calls over there. But yeah, that data should be in whatever comes back in the key there.
Yeah.
So my proposal would be that we'll go have a look if this is feasible with all the backends involved. And if possible, we could make it work this way, so we have the least amount of change required.
Yeah, for what it's worth, almost all backends use the same code. RBD has its own implementation because it uses different tooling for a lot of this stuff. And then the NFS driver does it similarly to RBD, but most drivers go through the same path other than those two.
Then we could keep the current behavior that Cinder uses internally, and we could enable user-supplied encrypted images in LUX format that Cinder would be able to process. Well, actually, now that I think about it, I guess this is completely the wrong code part, because isn't this about initializing the volumes? I think the correct code part would be when they are attached in Nova, actually, now that I think about it, because this passphrase stuff is only relevant if images provisioned outside of Cinder are used. So volumes initiated by Cinder don't count. So sorry, I guess this was the wrong code part. So the new behavior with passphrases being computed directly would only be relevant to the attach operation, would it not? Because what I linked is volume creation, if I get that right.
It depends on who's doing the LUX format, and if I remember correctly, in a lot of cases now, Cinder is doing the LUX format before it's attached to Nova.
Yeah, right. But if you're talking about the LUX commands, LUX format would happen outside the cloud, and we are talking about user-provided images that have a passphrase that is not to be Hexley-fied. The code parts that I linked to is about Cinder creating the volume, which is not what the user would do. I mean, this is the behavior that we could keep completely untouched. What I linked, we need to adjust the point where the volume is attached, because this is the crucial part, right? Isn't it?
Well, what's the operation? Are you talking about doing a boot from image with a volume?
So as I currently see the things, is like we want to reuse the LUX encryption. So the user can upload LUX encrypted data that is then used as is by Cinder as the volume blocks, right? So that we can keep the encryption and simply have the reference to the key. Then Cinder only really does not convert the image because it's already LUX encrypted. This is what I understood from Dan Smith, what he actually wanted, so that we don't have unnecessary conversions happening. So that it actually acts like what Cinder currently creates if you make an image snapshot of an encrypted volume. It writes the LUX blocks into the glance image. If you restore it, then Cinder simply transfers the LUX blocks again into the volume. But it does not do a LUX format because they are already LUX formatted. So the point where the encryption key is actually needed is when the volume is first attached. And that does not happen in the code part that I linked, because I thought about the wrong place. This is when it's attached to a Nova VM, I guess.
Well,
Go ahead, Eric.
Well, it just depends on what operations you're doing. I mean, if you have an image and you're doing something with it in Nova, then Nova's going to need to handle the key stuff. But if you're doing something with it in Cinder, then Cinder's going to need to handle the key stuff.
So maybe I understood the proposal earlier in an incorrect way, but what I understood is that we want to reuse the behavior that Cinder currently does when making image snapshots of encrypted volumes to also support user-supplied encrypted images. And if we reuse this, then Cinder wouldn't need to convert anything. It would simply use the looks encrypted blocks from the images as is, like it would do if the image was created by Cinder itself from an encrypted volume. It does not do any looks format or something on it because the looks blocks are already prepared. It simply transfers it into its backend and attaches the key reference to it. And the first time the key is actually used and looks open to speak in looks commands is used when Nova attaches the volume to the VM. This is my current viewpoint, but maybe I got it all wrong.
I mean, that's correct. But again, it just depends on the operation. I mean, if you're creating an instance, yeah, if you're going to clone a volume from an instance in Cinder, then Cinder will open it. But yeah, I mean, I think you've about got it right.
I mean, yeah, maybe there are places I haven't thought about yet where we would need to handle this distinction between the secret types correctly and then decide to hexlify or not to hexlify. Just wanted to point out that it was an error on my side. I thought about the wrong places when I linked this stuff, but the basic principle would stay the same. We'd based on the secret type attribute, we would decide whether to hexlify or not before processing the key. I mean, the call is already going pretty long, and I guess things getting not simpler by any minute here. So maybe we can come to some basic conclusions for now. I don't know. So I'd be interested if you would be open to introduce this kind of distinction in Cinder to handle both use cases. Then we would have good interoperability with both Nova and user-provided images, where user-provided images are still something to be actually defined or implemented, which is the major part of this contribution, actually. But to get the support in Cinder, we would change the architecture of the contribution to base the behavior on this secret type metadata. We would get rid of the GPG-based encryption and use the native looks encryption that Cinder uses by utilizing QEMU tools on the client side so that users are able to create this encryption. And by supporting the passphrase secret type in Cinder, we can support the expected passphrase behavior that users are expecting from looks-based encryptions. And for Cinder native operations like snapshot creation as a glance image or glance image restoration from a Cinder-based image, we'd keep the old behavior by having the secret type still being symmetric, not passphrase. And then the old hexlify behavior still works. And also if Cinder on its own wants to create an encrypted volume because the volume type specifies encryption, then it still goes to Barbican, asks Barbican to create a key for it, and uses the symmetric secret type. So nothing changes for the Cinder ecosystem, but as an extension, Cinder then supports other looks passphrase behavior, maybe from Nova, maybe from a user side. Would that be something you could basically agree with? This is the question.
I think it sounds good to me.
Yeah, I mean, off the top of my head, I don't have an objection to doing both.
And I haven't heard anything that is needed for Barbican at this point,
right?
As far as I understand.
So we've gone long enough, but the other complicating factors are Cinder assumes there's a one-to-one correspondence between a Barbican secret and any resource that Cinder controls. So we basically, I think currently we clone the Barbican secret to associate it with the volume. So the secret for the image is a different secret than the secret for the volume, but we don't guarantee that it's going to be the same secret when we rekey. I think it is now, but we don't guarantee that. So we may need to think about whether we want to guarantee it or whether we keep it as a right. Our scheme's designed for like as much randomness as possible, I think, and the ability to delete the secrets when you're finished.
Well, Glance's metadata has a field about can you delete this key when you delete the image. I forget what it's called, but there's some field there that
it's Cinder _ encryption key deletion policy or something like that.
Yeah. So if creating glance images, you may want to think about how to set that in the right way. And
well, also Barbican now has the secret
Right.
consumer API. So we did the deletion stuff before that, but now we can at least, we probably need to revisit that and redo it a little bit to take advantage of the secret API. I mean, consumer, is it secret consumers or consumer secret? It's secret consumer.
Secret consumers, yeah.
API. And then that way you register that the key is in use by something, I think. Well, anyway, we can look that up later.
Yeah.
I'm just tossing out something to be aware of with as we go through this.
There's also the possibility of setting other metadata on the secret as well too. So there's there are so if you need to use other metadata as well, that can be set on the secret, and you can read that when you read your other metadata. When you read the secret type, you also get the other metadata as well too.
Okay. All right, so Marcus, are you all set? You and Josephine?
Yeah, I mean, if you don't have a strong objection to that, I think Josephine and I would go ahead and change the spec, or maybe make a new one, because it's quite a major change by now, to write down what I kind of sketched in my last few sentences. So, and maybe then start looking into the finer details of it more, where to hexlify, where not to hexlify, which metadata attributes to introduce in Glance or not. But as a general picture, my most important question, I guess, has been answered now. So correct me, but I haven't understood any kind of major objection to this. So
Yeah,
I think
what I was going to say is we're kind of light on Friday, but I don't think John's going to cancel. So if you think it over the next day or so and have more questions or issues that come up, we can probably revisit this on Friday.
Yeah, no plans to.
I know you want to move this
We
along
haven't.
so it doesn't take 8 development cycles to do this again.
Well, yeah, and I'll just say thanks for continuing to work on this. I know it's been going for a while.
okay. I think that's a wrap for now. Thank you so much for the discussion. It wasn't, I guess it wasn't easy, but we now have a way forward, I believe. And I am strongly convinced that having this looks format really simplifies things. I mean, I said this before, but the major point there was that we hadn't have a method to have user side without root rights and de-encrypt to create this format, but with QEMU tools we now have, and introducing another encryption in the mix isn't going to simplify things, and I guess looks, especially now that Nova also does, is the right way to go here. And I'd really love to see this kind of ending up in a very coherent way, or at least as coherent as possible, without re-architecturing all the things in various components. So yeah, thank you for the talk. Really appreciate it.
Okay, John, I think you can close things up if you want to.
Sounds good. Yeah, we're a little over for today, so next topic starts tomorrow. Brian, we want to start at the scheduled time of 13, or we're pretty light. We could push it back, or we could start early and finish early. I don't know. Does anyone have any thoughts about this?
Yep. Start early, finish early. So Rajat doesn't have to
That's what I was
be
going to say.
midnight.
This is what Rajat says.
That's, yeah.
I'm fine with both, but yeah, starting early would be good.
All right, let's
All
stick
right.
with 13 and then see what happens, but plan to maybe end early and go work on our documentation patches.
Walter, are you still there? Do you have any, is starting at 13 going to work for you? Any chance?
13, what time is that here?
That's
9.
not
Or where
Eastern time.
are you?
Where you are, though.
I'm on the East Coast.
Okay, yeah, 9 a.m.
9 a.m. tomorrow? Yeah, that's fine.
Cool. All right, 1300 tomorrow morning. Thank you, everyone. This has been productive, and we'll see you.
Don't forget to
I will stop the recording. Yeah. I'm on it.
Don't forget to stop the recording.